Hi, in this session we are going to discuss doubly linked list. So the linked list, we know if in the memory, if I cannot find continuously the required amount of memory, I can use a linked list to store my data into the memory. So we have a singly linked list and doubly linked list already. So singly linked list, what a singly linked list is? I will be having the data and address of the next node. So this is how I can have the singly linked list. What is doubly linked list is? I will be having three informations in every node. I will be having the data and address of the previous node, address of the next node. For example, if this is the address A1, the node is in A1 and this node is in A2. So this node, there is no previous, so it will be null. And what is the next address is A2. For this particular node, what is the previous one is A1 and the next, there is no other next node, so it is null. So this is what the doubly linked list and this is what the singly linked list. So we saw many tasks can be done in the singly linked list. See, for example, if I want to traverse the node in both the directions. If I want to traverse in both directions, or I already told you how to delete a node from this, right? So in the same way, the doubly linked list, right? For example, if I want to traverse in both the sides in the linked list, it is difficult to do in the singly linked list because there is no provision to travel in the backward direction. Because in few applications, we need to traverse back also. For example, if I particularly I'm in the particular node and if I want to do traverse in the other direction. For example, I am here, I can traverse only in this way. I cannot traverse back to this D2. But in some applications, I need to check both the previous and the next one, for example. Then in that case, I cannot do it with the singly linked list. So for that particular scenarios, we can use this doubly linked list. So what is the advantage in doubly linked list is, if I am staying in a particular node, I can go back as well as I can go in the forward direction. The reason is every particular node contains the address of its next node and the address of its previous node. So if I am taking this particular node, it contains the data D2 and address of the previous node and address of the next node. So from a particular node, I can easily traverse in the forward node as well as in the backward node if it is represented in a doubly linked list. So the only disadvantage in the case of doubly linked list is additional memory is required to store both the addresses. Because in the singly linked list, we are going to store only the forward address. In the doubly linked list, we have to store the forward address as well as the backward address. See, let's take a simple doubly linked list. As I said, the first node will not have a previous node. So the address of the previous node of the first node should be null. And there should not be any next node for the last node. So the next address of the last node should be null. Right? And every node, other node, will contain the next address and the previous address. So in this case, how can we do the insertion and deletion? See, for example, I am going to insert a new node with the data D23. So the data D23 I am going to insert in between D2 and D3. So how can I insert this node in between D2 and D3? So imagine I arrived with the node A2 contains the data D2. Now I have to insert this here. So what should I do? As I told already, the address of the next node contains the address of the node in which the next data got stored. Now, as of now, the next node for A2 is A3. But I have to make that the next node of A2 is A23. Imagine this is the address of this particular node. So I have to update A23 here and I have to update A3 here. As well, the previous and the next node of this also should be updated, right? So how many updations we required here? In the case of singly linked list, we need 2 updations. In the case of doubly linked list, how many updations we need? I need to update the next address of A2, then previous address of A3 and previous address of A23 and next address of A23. So that I can logically include this node in between A2 and A3. So how I can do this change? See, for example, I am placing a pointer P to hold the P1, right? So I am moving to the next node from the first header node. Now I am standing here. I have to include my new node in between the node which is represented by P and its next node. So P represents this complete node. So this is P of previous address. Now we can have the structure with one data and two pointers. One is next pointer, other one is previous pointer. Both of type struct, because it is going to point another structure node, right? So this is next P, this is data and this is previous P. So if I am placing the P in this node, this pointer P is pointing. The pointer P contains the address A2, meaning this pointer is pointing to this node. So what is P of A1? Is the previous address which is stored in this particular node. P of data is D2 and P of next node will be containing the address of the next node here. So imagine I am standing here and I am going to add this node in between this two, A2 and A3. So what can I do is, first I have to copy properly, right? So first I can copy these two values into this node so that the loss of data will not happen. So consider this is my new node NN. So I have NN of previous pointer, NN of data and NN of next pointer. So these three will be the data in the new node. Already I loaded D23 as a data of this NN. Now I have to load what is previous P of NN and next P of NN, right? So what should be the previous P of NN? This is my new node. When I include this node into this linked list in between this two nodes, what should be the previous address of this NN? The previous address of the NN should be A2. So where it will be? It will be in P of next of previous pointer, because see, this is the node I created separately and this is the existing linked list as of now, and I know only the pointer P pointing this node. So my pointer P next contains the address of this one and this node contains the previous P of this node. So what should I do here? The NN of previous P I am going to store this point. I have to store P of next of previous, right? So my P of next of previous contains the address of this previous node. So this I am going to store here by this line. And what is next P will contain? The next P should have the address of this particular node, because I am going to insert in between these two. So where this address is residing right now, it is in P of next. So I am copying this P of next pointer here, right? And logically I made this node. So hereafter this node, previous node will be A2, next node will be A3. Okay, so this will be existing. And this next will be existing. Now I need to change these two pointers. That is, next node of A2 should be this A23 and previous node of A3 should be this A23. So that how can I do? I have to break this and I have to update. So now P of next P, that is this pointer, should hold the address of A23. That is our NN. So NN will be the next node of this one. So this will contain A to 3, which means the next node of this will be changed to here. Now this pointer I have to change. The previous node of A3 should also be A to 3. So what should I do? What should I do is, now I have removed this pointer P, but I know NN, right? So NN of next P of previous. This is my NN. NN of next points to here. This previous is here. So this previous I am updating with NN. So this will be pointing here after this one. A to 3 will be copied. The address A to 3 will be copied here. So these lines I have to do to make an insertion into my doubly linked list. Right? How to do a deletion? See, for example, imagine right? Imagine I have a doubly linked list like this, right? So the next of A1 is A2, the previous of A2 is A1, next of A2 is A3, the previous of A23 is A2, and next of A3 is A4, and the previous is A3, and that is null. Now I am going to delete this particular node. In the case of singly linked list, I have to stand a step ahead and I have to change the pointers to do the deletion of a node. But here, right, how many changes I should do? So I am going to logically delete this. So what should I do? I have to change the two pointers, that is next of this one should be this one, previous of this one should be this one, and I have to remove the pointer values from this A3. So how can I do that? If I am standing here, this is the node to be deleted. So how can I write the code to do the deletion? As I said, I have to copy this A4 into here. That is, the next node should be A4 and the previous of this should be A2. So how can I do this? P of previous of next should be this P of next. Okay. This P of previous pointer points to previous node. In this particular node, what should be my next pointer? The next pointer should be my P of next. So this value will be copied here. So this will be updated to A4, right? So this next should be pointing here, right? And at the same time, P of next of previous, P of next node of previous should be A2. So where the A2 is existing, as of now I know only this P. So P of previous P. So this will be changed to A2. So this node will be pointing here. Right? Now the flow is correct. After A2 is A4. Before A4 should be A2. But now this I have to delete this node. So what should I do? P of previous of P, P of next of P should be null. So I am making these two pointers as null. So this will be logically got disconnected from the linked list, right? So A1, A2, then A4. What is A4 of previous is A2. What is next of A2 is A4. So both the pointers. So these three lines I have to do. I have to write delete the node from the doubly linked list. So what is the advantage of using this doubly linked list is, from a particular node I can traverse either in the forward direction as well as in the backward direction. So which cases I can use this doubly linked list? Simple example, palindrome, checking palindrome, whether the given string or a number series. It's a palindrome. That is, when I start from first to last or last to first, both sequences will be same. If I want to do this, what can I do? I can start from the middle and I can keep on comparing the next nodes. So for that case, I can use this doubly linked list, and it also has its other applications as well, where from a particular node I should traverse both in the forward as well as in the backward direction. So that is the use of doubly linked list when compared to the singly linked list. So only one disadvantage in the case of doubly linked list is we need some additional memory to store the previous address also when compared to the singly linked list. Thank you.